Good morning. Good morning, everyone. Good morning. Just tell me in the chat section, are we live? Are you able to hear me? Good morning, everyone. Good morning. Good morning. How are you all? How are you all? Yes. Yes, yes, yes. A very, very good morning to everyone. Very good morning. Very good morning. All right. Let me see. Just tell me in the chat section. Is my audio clear? Is my video clear? Just give me a thumbs up in the chat section if my audio and video is clear. Just give me a thumbs up in the chat section. Good morning, Artery. Good morning. How are you? I'm good. I'm good. I am also very, very good. I am also very good. All right. All right. So, I welcome you all to Unacademy, India's largest education platform. This is Let's Crack NEET UG English platform. All right. We'll be study in English in this particular channel. All right. So, I welcome you all here. Let me introduce myself. I'm Nitesh Devnani. I have 5 years of teaching experience and I have taught over 2000 plus students who have got some great marks in your NEET examination. Alright, this was my introduction. Let me tell you about the subscription plan. Let me tell you about the subscription plan of Unacademy. What are benefits you will be getting if you purchase this subscription plan? Alright. First of all, you need to download this Unacademy learning app. Alright. Whenever possible after this session, just download this Unacademy learning app. Alright. Yes. See, there are two types of subscription. First is your plus subscription. In the plus subscription, you'll have daily live classes. There will be live test and quizzes. You'll have structured courses as well as you'll be given unlimited access. Unlimited access means you guys can access these classes, these tests whenever you are comfortable. Alright, and lot of educators on our platform. Alright. Now the second type of subscription is your iconic subscription. You will be getting all the benefits of Plus. First of all, you will be getting all the benefits of Plus, as well as you'll have a personal coach who will guide you throughout your journey. You'll have your test analysis so that you should know what are your weak points, on what topics you need to work on, and you will be given a study planner also, which will be revised on a bi-weekly basis and which will be reviewed continuously, so that your your preparation can be on track and we guys can help you in our preparation. All right, this was about the iconic subscription. See, in the plus subscription, you'll have your India's best educators, you'll have interactive live classes, there are structured courses and PDF as well as live test and quizzes. In the iconic also you'll have all these things you'll have in our iconic, but a student needs a personal guidance, a student needs a personal coach. So in the iconic subscription, Unacademy has bring you personal coaches also. All right, study planner, these are some expert guidelines which will be helping you a lot, and you'll have your test analysis. All these are in iconic subscription. See, there are free classes also. You just need to download. You just need to download Unacademy. You just need to download Unacademy learning app. Just need to download Unacademy learning app. Alright. Yes, see, these some of the educators on our platform. Let me tell you about the pricing. Whether you are planning to buy the plus subscription or iconic subscription, you always have to apply this code. Nitesh is my name. Nitesh YT is my code. Nitesh YT complete. Alright, this is my code. Whenever you will apply this code, you'll have 10% off. 10% off would be given to you. Alright, so 6-month course you'll be getting at 34,200 rupees. 12-month course you'll be getting at 58,500 rupees, and 24-month course you'll be getting at 90,000 rupees. You just need to apply this code Nitesh YT. Alright, and about the plus subscription, again you need to apply this code Nitesh YT. Alright, Nitesh is my name, Nitesh YT is my code. Alright, Now, if you are a dropper or if you are in 12th standard, I would recommend you to go for a 12-month course. Alright, after applying this code, you'll be getting it at 34,650 rupees, and 24-month course. If you are in 11th, go for 24-month course. That would be cheapest. Alright, 24-month course would be at 50,400 rupees. Alright, don't forget to type to write the code as Nitesh YT. You will be getting 10% off. All right, I'll be also benefited and you will be also benefited. All right, okay. So see, good morning everyone. Good morning Keshav. How are you? I'm good. Yes, let me see in the chat section who all are present. Let me see in the chat section who all are present. Then let us start our lecture. Okay, this is lecture 6. All right, this is lecture 6, atomic structure, lecture 6. Yes. Good morning Tamil. Good morning. Try to come on time guys. 9:30 a.m. is our class timing. All right, try to come on 9:30 a.m. only. Good morning Nishtha. Good morning. Okay. Great. Good morning, Rahul. Good morning. Okay, so do you guys have any doubt in our previous lectures? Do you guys have any doubt in our previous lecture, which we were studying atomic spectrum? We have completed atomic spectrum in our previous class, right? Hydrogen spectrum we have completed. All right. Now today we are going to study about de Broglie wavelength as well as your Heisenberg uncertainty principle. Alright, we are going to study about de Broglie wavelength and Heisenberg uncertainty principle. Yes. No doubt. Shall we start our today's lecture? Just give me a thumbs up in the chat section. Let's be active in the chat section, guys. It's good morning. It's very good morning. Let's be active in the chat section. Alright. We are going to study about de Broglie wavelength. De Broglie wavelength. All right, de Broglie wavelength. Great Tamil, Atri, Nishtha. Fantastic. All right. Okay, we are going to study about de Broglie wavelength. All right, let us start. De Broglie is the name of a scientist. De Broglie is the name of a scientist. Good morning, Kalei. Good morning, Ilakya. Yes. All right. Now let me first give you definition of this. What de Broglie suggested. De Broglie suggested that whenever a particle is in motion means it has some speed, it has some velocity. All right, de Broglie suggested that whenever a particle is in motion, all right, it should have wave nature also. All right, and its wavelength is inversely proportional to its momentum. Let me explain you this. Right, have we studied dual nature of light? Just tell me in the chat section, have we studied dual nature of light? I've told you that light has wave nature also, light has particle nature also. Correct. So there is a dual nature of light. Correct, there is dual nature of light. We have studied this. Similarly, there is dual nature of matter also. Means if there is any particle, suppose we are a particle, Yes, we humans are a particle, alright, or we humans are a matter, alright. Now, De Broglie suggested that whenever a particle, suppose let us take example of humans, is in motion, suppose we are running, alright, a particle is in motion, it should have wave nature also. If any particle, I am a particle, you are a particle, a car, bike, electron, proton, these are what mainly particles. But if they are in motion, they must have wave nature also. Means a wave should be associated with that particle, and its wavelength of that particle is inversely proportional to its momentum. Momentum is p. This was suggested by your De Broglie. All right. Okay. Let us simplify this. Lambda equals to, if I put a proportionality constant, is h upon p. What is h? H, you already know this. This is your Planck's constant. All right. Now see, momentum can be expressed as your product of mass into velocity. So your lambda is what? H upon mv. Momentum is your mass into velocity. Are you getting my point? Is this thing clear, guys? So there is dual nature of everything in the universe. There is dual nature of matter also, there is dual nature of light also. Light can behave as particle as well as wave. Matter can behave as particle as well as wave. Are you getting my point? All right. Lambda equals to h upon mv. These are your right now two formulas. I'm going to derive one more formula. Yes. All right. Okay. Okay, just pay attention here. Let just see this derivation of this. Then we'll do questions. Don't worry, we'll do questions on it. All right. Your first formula is lambda equals to h upon p, or you can write it as a lambda equals to h upon mv. All right. These are your right now these two formulas. All right. Now, from the starting, you must have heard kinetic energy. The formula of kinetic energy is what? Half mv square. Correct. Let us arrange this. Something. Just take 2 this side. So 2 ke equals to mv square. Just multiply on both the side with m. So 2 m ke equals to m square v square. Correct. This would become m square, na? If we are multiplying on both the sides with m. Let us take root. So one taking root, this would come out to be mv, and this would come out to be 2 mke. Correct. Are you getting my point? Now, yes, you must be thinking correct. This mv, I'm going to replace it with 2 mke. So your lambda is coming out to be h upon 2m kinetic energy under root. This is your third formula. Is this thing clear, guys? Are these three formulas clear to each and everyone? Give me a thumbs up in the chat section. Then let us move on to our questions. Is it clear? Just give me a thumbs up or yes. Great, Keshav Battery. Fantastic. All right. Great, Tamil. Yes. Let us do some questions. Great, Ilakya. Yes. Yes, Nishta. Yes. All right. We are calculating de Broglie wavelength because every matter in this universe has dual nature. So if there is a particle, suppose you are a particle, Kunal, you are a particle, right? And if you start running, there would be a wave associated with it, and you can find the wavelength of that wave with the help of your momentum or kinetic energy. That's why we are studying this. All right. Okay. Now let us see some some of your questions. Calculate wavelength of a car. Calculate wavelength of a car of mass 2000 kg moving with a speed of 50 meter per second. Moving with a speed of 50 meter per second. Amisha, this is our we have just started our class. Don't worry. Yes. Neha, right now there is no such news. Yes. Okay, calculate this. Take your copy and pen. And give me answer. Give me answer in the chat section. All right. Yes. Give me your answer in the chat section. Okay, okay, Artery. We'll see. We'll just check. Don't worry, we'll just check. Alright, this is pretty easy. What is the formula? What is the formula which you have studied? Lambda equals to h upon mv. Correct? Your mass is given to you as 2000 kg. Alright, always mass has to, you have to keep it in kg only. Your velocity is 50 meter per second. So both the units are also good. So lambda equals to h upon 2000 into 50. This is h upon, this is basically 10 and 1 2 3 4. So basically this thing, this is your answer. All right, this is your answer. Now you can put the value of your this h 6.626 into 10 to the power minus 34. All right, upon 10 to the power 5. This is 10 to the power 5. It will go upwards. It will be 6.626 into 10 to the power minus 39 meter. This is your lambda. All right. Is this correct? Yes. Perfect. Is this correct, guys? Now tell me, isn't it very small? Tell me in the chat section, isn't it very small? Minus 39. 10 to the power minus 39. It is very small. Right? Tell me in the chat section, isn't it very small? 10 to the power minus 39. Yes. So why is it very small? Because the mass is very large. Alright. So if the mass is more, suppose if we try to calculate a wavelength of humans, then also lambda would come out to be very less. Alright. So it is that much less. We cannot measure up to 10 to the power minus 39. This is a hypothetical value. We don't have instruments to measure wavelength of this small size. Alright. So basically there is a note. Significance of de Broglie wavelength. De Broglie wavelength is significant for microscopic particles. For microscopic particles like your electron, proton, neutron, etc. But not for macrospecific particles like your humans, cars, etc. Why? Because for macroscopic means large particles having great mass. So if the mass would be more, your wavelength would be very less. So we cannot measure it. but if the masses of protons, electron, proton and neutron are very less, so their de Broglie wavelength is significant. We can measure that wavelength. Is this thing clear? I've explained you with an example also. The mass was 20,000, sorry, 2000 kg. The wavelength was very, very less. All right. All right. Is this thing clear, guys? Yes. Great. Great. Let us do some more questions. Let us do some more questions. All right. Let us do some more questions. All right. Question is, if kinetic energy of a proton is increased 9 times, the wavelength of de Broglie wave associated with it becomes ये this is being asked. Your options are 3 times, 9 times, 1 by 3 times, and your 1 by 9 times. These are your options. Yes, these are your options. Do this question. Lot of questions we'll practice. Don't worry. We'll practice lot of questions. Your formula was lambda equals to h upon 2m ke under root. Alright. In terms of kinetic energy, this was your formula. Pretty easy question again. Pretty easy question. Everyone give me your answers, then I'll give you one more question. Yes, most of them are saying C answer. Most of them are saying as C as your answer, third option as your answer. Yes, it is your third option only. Yes, it is increased 9 times. So see, kinetic energy becomes 9 times. All right. So if you will write it down as a lambda upon 2m into 9 ke under root. All right. Just take out this 9 outside this root. This would come out to be 2m ke into 3. All right. Now this is your old lambda. Alright, so new lambda is what? Lambda by 3. Yes, it becomes 1 by 3 times. Yes, pretty easy question. Correct? Is this question clear to all of you? Is this question clear to all of you? Let me give you one more good question. This time, a good question I'm going to give you. Yes. Alright. Great. Fantastic. Alright. The question is calculate ratio of wavelength of alpha particle to proton if ratio of kinetic energy of proton upon kinetic energy of alpha particle is 1 by 4. All right. Alpha particle, I'll tell you what is alpha particle. I've explained this before also. I'm again explaining it. Alpha particle is helium atom having 2 charge, plus 2 charge. All right. And proton, you all know what is proton. Proton we can write it as p11. We can write it as 11. All right. Yes, Keshav. Yes, yes, yes. They might be useful in your in that chapter also. Yes. The basic understanding of that chapter you'll get in chemistry only. All right. Attempt this question. Yes. Okay. Okay, Nishta. We'll check. We'll check. Don't worry. I need everyone's answer, whether it is correct or whether it is wrong. That is not the issue. Everyone should just give answers. Alright, there is an announcement also in the end of the lecture. I'll just announce also about the special class. About the special class, sir, I will have an announcement after your class. Alright. Yes. Ratio of wavelength of alpha particle to proton. Yes. Where you guys are facing difficulty, tell me in the chat section. Where you guys are facing difficulty. Yes, yes, Kunal. Nishta, I need one answer. Nishta, I need only one answer. Okay, Supriya has given answer. Sanya has given answer. Atri has given answer. Okay, okay, okay. What are your final answers? Just tell me. What are your final answers? No, Sampreet. I'm teaching for the since the last month. I'm teaching here since October. All right, all right. All right, let me do this question for you all. Let me do this question for you all. All right, just pay attention here. Just pay attention here. All right. Now, when kinetic energy is given to you, the formula which you need to apply is lambda equals to h upon 2m ke under root. Correct? The formula which you need to apply is this. Correct? Now see, you need to find the ratio of wavelength of alpha particle to your proton. So lambda of alpha equals to h upon 2 mass of alpha, kinetic energy of alpha. Correct? Correct? Okay. Lambda of proton is h upon 2m mass of proton, kinetic energy of proton. Correct? You need to find a ratio. You need to find a ratio. So let us divide. Let us divide this. All right. If we divide this h and h cancels out, this 2 and 2 cancels out. Correct? So your ratio is coming out to be, I'm writing it here, your lambda of alpha upon lambda of p is coming out to be, this will go upwards, this will go upwards, this is coming out to be whole under root mass of proton, kinetic energy of proton upon mass of alpha, kinetic energy of alpha. Correct? Now see, kinetic energy of proton is to kinetic energy of alpha. Your ratio is given to you as 1 by 4. Correct? 1 by 4 it is given. You need to find the ratio of your masses. Now see, what are the masses? what are the masses of your proton? Proton mass is this. It is being asked atomic mass. You need to write atomic masses. Here it is 1, here it is 4. Alright, so proton mass is 1, so it is 1. And your alpha particle mass is what? 4. So it is 1 by 4. So just if you solve this, this is 1 by 16 under root. This would come out to be 1 by 4. Lambda of alpha upon lambda of proton. This is your answer. This is your answer. 1 by 4 is your answer. Is this thing clear? Tell me in the chat section if this thing clear, guys. See, kinetic energy ratio is being given to you. Alright, 1 by 4. Proton mass is 1, na? Alpha particle mass is 4. So just we have put 1 by 4 there. Just we have put 1 by 4 there simply. Alright, we have our regular classes at 9:30 a.m. You guys can attend our regular classes at 9:30 a.m. Okay? Yes. Is this question clear to each and every student here? Tell me in the chat section. This was a good question. Alright? You need to know these type of questions. Is this thing clear? Yes, Rahul, yes. Great Elakya, great Supriya, great Sanya, Artery, fantastic, great Tamil. Yes. Alright. So see, these are different type of questions which can be asked in your de Broglie wavelength. Okay. Yes, Kunal, yes. Great Kalai, yes. Now another phenomena which we are going to study is Heisenberg uncertainty principle. Alright, this thing also we are going to study. We call it as HUP. Yes, Nishtha, you can surely keep it also, but see, if you will keep, now just pay attention here. Nishtha is asking, sir, but here mass of proton should be 1.67 into 10 to the power minus 27. Perfect. Kg. That is perfect. Alright. What should be the mass of helium then? Tell me, what should the mass of alpha particle then? Tell me here. What should be the mass of alpha particle here? It is 4 times, na? There you have your 2 proton and 2 neutron in your helium atom. Alright. And proton and neutron are almost same mass. What should be its mass? Its mass should be 4 into 1.67 into 10 to the power minus 27 kg. Alright, let us take the ratio of it. You guys, this thing would cancel out. Ratio would be 1 by 4. 1 by 4. Alright, so directly you can do it with this only. This is your 1. This is your 4. Just simply put these values. Is this thing clear now? Is this thing clear now? Alright, yes. Now let us start our lecture, Heisenberg uncertainty principle. This is, we call it as HUP also. Yes, Kunal. Now, according to Heisenberg uncertainty principle, it is impossible to find the position and momentum. It is impossible to find the position and momentum of electron with accuracy simultaneously. Alright, means it is saying that electron is present. You cannot determine its position as well as its momentum simultaneously with 100% accuracy. There has to be some error. Alright, let me give you mathematical term for this Heisenberg uncertainty principle. Let me give you mathematical term. Mathematical term is delta x into delta p is always greater than equals to h upon 4 pi. Now let me tell you what is these. What is delta x? What is delta x? Delta x is uncertainty in position of electron. Uncertainty in position. Delta p is uncertainty in momentum. Now what do you mean by uncertainty? What do you mean by uncertainty? Simply uncertainty means error. Uncertainty means error. You must have studied a unit and dimensions in your physics chapter. So for that error thing, you write this thing na, delta x, delta t, how much error is present, how much uncertainty is present in this in the instrument, whether it is 5%, whether it is 2%, right? So uncertainty means what is the error you are doing in finding position of electron. All right, delta p is what is the error you are doing in finding uncertainty in momentum, in finding momentum. All right, now let me tell you one more formula for this. See, delta x, wait, delta x into delta p is greater than equals to h upon 4 pi. This was your first one. Okay, if all right, delta p can be written as delta mv, correct? Momentum can be written as what? Mass into velocity, na? If mass is constant, if mass is constant, then this would come out of this delta. Mass is constant, na? Then change is only due to velocity. So delta p is what? M delta v. Therefore, if mass is constant, we can replace this delta p with m delta v here. So it becomes delta x into m delta v is greater than equals to h upon 4 pi. Alright, or mass is your constant, just take it down. So delta x into delta p is always greater than equals to h upon 4 pi m. When is it possible? When is it true? This is true if mass is constant. If mass is constant. If mass is constant, this is correct. Alright, this is your first formula kind of thing. This is a second formula. Alright. What is delta x? Delta x is uncertainty in position. Alright, what is delta p? Delta p is uncertainty in momentum. What is delta v? Delta v is also here, na? Delta v would be uncertainty in velocity. Uncertainty in velocity. Alright, these are your three notations. Is this thing clear, guys? Tell me in the chat section if this thing is clear. Tell me in the chat section if this thing is clear. Alright. Great, Dinesh. Yes, Rahul, our train Insta, Tamil, fantastic. Great, Supriya. Yes. Alright. Now see. There is one more thing. Great, Kalai, great, Alakya. Yes. Delta x into delta p is greater than equals to h upon 4 pi. Correct? This was your first one. Yes. Now see. If delta x is tending to 0, if delta x is tending to 0 means this thing, uncertainty in position is tending to 0, means error. Uncertainty means error in position is tending towards 0, then your error uncertainty. See, if this is tending to 0, so 0 into delta p, h upon 4 pi. Delta p would come out to be what? H upon 4 pi into 0. Anything divided by 0 is what? Infinity. Anything divided by 0 is what? Infinity. If delta x is tending towards 0, means error towards position is tending towards 0. This means then delta p, means error in momentum, would reach out to be infinite. Alright. Similarly, if error in momentum you would reach out to be 0, then delta x would go towards infinity, Is this thing clear, guys? Alright, pretty simple. This is also very simple. Alright. Yes, now let us do some questions. Based on it. Let us do some questions. Alright, great. Let us do some questions based on it. A question is, a golf ball has a mass of 40 gram and a speed of 45 meter per second. 45 meter per second. Yes, Dinesh. Yes. Correct. Now, if the speed can be measured, within accuracy of 2%, calculate uncertainty in position. All right. Calculate uncertainty in position. Try this question. Yes. Perfect, Kunal. Yes. Calculate this question. Yes, everyone. Come on, everyone. Yes. Yes, this is a bit calculative, right? But what important thing you need to learn? what important thing you need to learn from here. All right, your mass is given to you as 40 grams. First of all, you need to convert it into kgs. All right, first of all, you need to convert it into kg. 40 into 10 to the power minus 3 kg. This is your mass. All right, now see, what is your velocity? Velocity is 45 meter per second. Now please pay attention here. Please pay attention here. You are given in your question, you are given velocity is being given. All right, you need to find delta v. In our formula, you need to find delta v. Now delta v is what? 2% accuracy. It is measured with 2% accuracy. It is basically 2% of your v. All right, you need to find delta v. You cannot put directly the value of velocity. No. So 2 upon 100 into your velocity is 45. This is coming out to be 0.9 meter per second. This is your delta v. Is this thing clear? Now see, now you are being asked is, now the formula is delta x into, you are being given delta v na, and mass is constant. Mass is constant. Delta v equals to h upon 4 pi m. Now see, just pay attention here. In solving your questions, you can apply this equality. All right, see, in our main derivations, there is no equality. You have your greater than equals to sign, correct? But in solving questions, you can surely apply equality. Okay, now see, you need to find delta x. All right, delta v is what? 0.9 equals to 6.626 into 10 to the power minus 34 upon 4. Pi value is 3.14. Mass is 40 into 10 to the power minus 3. So delta x is simply what? You can calculate delta x from here. Are you getting my point? You can calculate delta x. Yes, this is a bit calculative, but the main point which we need to learn here was mass you have to take in kg and velocity was given to you. You need to find delta v with the help of 2% accuracy. Is this thing clear, guys? Is this thing clear, everyone? Is this thing clear? Is this thing clear, guys? You need to find uncertainty in position. We aren't talking about wavelength. This is uncertainty in position. Delta x you need to find. Great Artery, great Supriya, great Keshav, Rahul, Nishtha, Ilakya, great Kunal. Yes. Alright? Alright? Yes. Now see. Great Tamil. Yes. So this type of questions are being asked to you. There is one more question which I am going to give you. One more question. Alright? Let us do one more question. Great Kalai. Yes. Question is calculate uncertainty in velocity. Calculate uncertainty in velocity if uncertainty in position is equal to uncertainty in momentum. Alright, now just please wait. You need to give me your answers. In terms of constant. Your h, your 4, your pi, your m. You need to give me your answer in this terms, in these unknown terms. Assume mass as m. You don't need to solve anything. I'm reducing your calculations. Just give me answer in terms of unknowns. h, 4, pi, m. Alright? Okay, attempt this question. attempt this question. Okay, I've reduced your calculations. You just need to give me your answer in terms of this. Yes, what should be your answer? What should be your answer? I've reduced your calculations, all right? This question is also pretty easy. This question is also pretty easy. Some answers are being coming out. Yes, yes, yes. Don't forget this M. Don't forget this M. Just assume mass as your M. Just assume mass as your M. Just assume mass as your M. Yes. All right. All right. All right. All right. Okay. Okay. Let me solve this. Let me solve this. What is given to you if uncertainty in position is equal to uncertainty in its momentum? Means delta x is equals to delta p. You are given this delta x and delta p are what? Same. Correct? Now, what was your equation? Your equation was delta x into delta p is equals to h upon 4 pi. Correct? Now, both are same. Both are same. So, this delta x, I can replace this with delta p. So, basically, it is delta p square equals to h upon 4 pi. Correct? Your delta p is coming out to be under root h by 4 pi. But this is your delta p. You are being asked uncertainty in velocity. So uncertainty in delta p, you can write it as, I am writing it down here, delta p you can write it as m delta v equals to under root h by 4 pi. So what is delta v? Delta v is 1 upon m under root h upon 4 pi. This is your answer. This is your answer. This is your answer. Yes. How many of you were correct? Many of you were not able to answer in the chat section because this is pretty difficult to write in the chat section. But tell me in the chat section how many of you were correct. Right? This is your answer in terms of h 4 pi m. All right, no need of calculations. You don't need to worry about calculation part. All right, so these type of questions are being asked to you. Yes. No issue, Rahul. No issue, no issue. Great, great, Nishta. No, this is the only way, Atri. This is the only way in which you need to do this. There's no another way. All right. Okay, okay. Great, great. No. Why would you take delta x square? Why would you take delta x square? We need to find a delta v. We need to find delta v. For that, you need to know delta p, na? For that, you need to know delta p. No issue, Keshav, no issue. All right. Now is it clear? Any question? Okay, ask me your questions. If you guys have any doubt, ask me your doubts. If you have any doubt, you can ask me. I'm waiting for you. Then I will proceed further. Only after your doubts, I will proceed further. Tell me in the chat section, are you practicing questions? Just like this video if you are able to understand everything, right? Are you practicing questions? Are you practicing questions? Tell me in the chat section, are you guys practicing questions? There are only few classes of atomic structure is left. Then your atomic structure, we are going to wind up your atomic structure. I really don't know about the doubts, artery. The doubts, I really don't know about it. There is no such difference as such. There is no as such difference, Nishta. Yes. Yes, yes. Keshav, you will be able to solve these. Don't worry. You will be able to solve as we proceed with our chapters. I'll do some practice questions also. Don't worry. Don't worry. Yes. Shall we move further? All right. All right. Now see. Before your 2-3 lectures, yes, yes, Nishta, I'll be taking class on your this also. Great, great urban samurai, great. Yes, thank you, thank you. Yes, all right. So, 2-3 lectures before, we were talking about your Bohr model. Correct? We were talking about a Bohr model. So there are some limitations. There are some limitations for your Bohr model. There are some limitations for your Bohr model. All right. So what were those limitations? Limitations of Bohr model. Limitations of Bohr model. All right. What were the basically limitations of your Bohr model? So let me tell you about the limitations. First limitation was it was applicable. It was applicable only for single electron species. It is applicable only for single electron species. Correct? Correct? I have explained you this only on hydrogen, helium plus 1, lithium plus 2, beryllium plus 3. Only on these type of species your Bohr model was applicable. Correct? Correct? Now second point was, second limitation was it is not consistent. It is not consistent with de Broglie. It is not consistent with de Broglie wavelength and Heisenberg uncertainty principle. All right. Why? Why? See, de Broglie wavelength. De Broglie wavelength. Just please wait. Yes. Yes. De Broglie wavelength. Your de Broglie wavelength was told you that every matter has dual nature, but Bohr was talking about that electron is only particle. Electron, Bohr did not consider electron as a wave, so it was not consistent with de Broglie wavelength. Okay, now about Heisenberg uncertainty principle. What about Heisenberg uncertainty principle? Yes, Amisha, in your school examinations you can be surely asked. In your Heisenberg uncertainty principle, now see, you cannot determine the exact position of an electron. See, Bohr told you that this is your nucleus, this is your electron. Correct? This is your nucleus, this is your electron. Bohr told you this. Correct? Now, if according to Heisenberg uncertainty principle, this position of this electron, you cannot find it. You cannot find the position of your electron. Alright, you cannot find the position of an electron according to your Heisenberg uncertainty principle. There always has to be some error. Alright, so it is not consistent with de Broglie wavelength and your Heisenberg uncertainty principle. Alright, this was your second limitation. Let's focus on our lecture. Don't worry. Let us concentrate on lecture, everyone. I'm telling everyone that let us concentrate on lecture. All right, don't type anything in the chat section. It's all just focus on your this lecture. Okay, now see uh, there was atomic spectrum also. In this atomic spectrum, there were different spectral lines which I have explained you. The third limitation was it could not explain, it means Bohr model could not explain splitting of spectral lines in presence of magnetic field. Now see, if a magnetic field was being applied on that the spectrum which we were observing, so there were small lines which were observed. Bohr model was not able to explain what are these lines. This is known as Zeeman effect. All right, similarly, fourth was it could not explain splitting of spectral lines in presence of electric field. All right, again electric field is applied, then also these different lines were being observed. Again, Bohr was not able to explain this. This is known as Stark effect. Now there is only sometimes question are being asked from this. What is like in presence of magnetic field, it is what Zeeman effect. In presence of electric field, it is what Stark effect. Correct? How to remember this? You need to remember that with magnetic field you have your Zeeman effect, your electric field you have your Stark effect. How many of you have seen Iron Man? Tell me in the chat section, how many of you have seen Iron Man? How many of you? Hello Priya, hello Ajay, hello. How many of you have seen Iron Man? Yes, yes, great Priya, great Ajay, yes, great Artery. You guys have seen this, correct? Yes. So in Iron Man, you have your Tony Stark. You remember your Tony Stark? Yes. So Iron Man was all about electricity, right? It is all about your electric gadgets and everything, right? It is all about the electric gadgets. Great Kalai, great Nishta. Yes. So you try to remember with it that electric field means your Stark, Tony Stark, Iron Man. All right. Yes, Artery. Rahul, no issue, no issue. Ilakya, no issue. Great Keshav, yes. After your exams, you watched all those movies, all right? Yes. Great Urban. You for the for the last 15-20 minutes, you are just spamming on our chat section. Your exams, I request you. Your exams are very near. If you're not able to understand from me, but if you are able to understand from other teachers, just go and study. All right, your lectures are very near. Your exam is very near. All right. I request you to study. Okay. Yes, if you're not able to understand from me, that is perfectly fine, no issue. You guys can go any other lecture, but just study. I would just request Urban Samurai to please study. Okay, this right now that is very high time. You have your you must, if you are in 12th standard, you must be having your board exams. All right. There is uh, there is a NEET exam coming very soon. So I would just request you all to study. All right. Yes. Okay. Do you guys have any doubt, guys? At 9:30 a.m. All right. At 9:30 a.m. I'm seeing some new students. At 9:30 a.m. we have our regular classes. Okay. You guys can come at 9:30 a.m. All right. All right. All right. All right. Yes. Any doubt? Any doubt, guys? Do you have any doubt? Yes. Do you have any doubt? Okay, Artery. Okay. Guys, any doubt? Okay, Ajay. Okay. Yes. So now see, now in our atomic structure chapter, you have your wave, you have your quantum model left, right? All those your subshells, SPDF, this is your quantum model is left. All right. So I'll be just taking, I think so, two classes or three classes, right? 2 to 3 classes more, and we'll be completing our atomic structure also. We'll be practicing lot of questions in those chapters only. All right. We'll be practicing questions also in our chapters. All right. Yes, 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 yes. Okay, so we'll be completing our atomic structure. We have completed GOC. All right, we have completed GOC. Hydrocarbons also I need 2 3 lectures. We have completed mole concept. All right. Atomic structure and hydrocarbons would be completed in the next 2 to 3 days only. All right, no, 2 to 3 classes more. So our 4 chapters would be completed. Just start practicing, guys. Just start practicing. Our preparation is based on your PPP model. How many of you can tell me what is PPP model? How many of you can tell me what is PPP model? How many of you can tell me what is PPP model? No idea? Okay, I'll tell you. Our preparation is based on your, yes, our preparation is based on your practice, practice, and your practice. PPP model. Practice, practice, practice model. All right. Yes. Priya, surely we'll have a practice session. Surely we'll have a practice session. All right. Just keep practicing questions. The more you practice questions, the better you will be in your theory, things. The better you will be in your theory things. All right. Just practice, practice, and practice, and you will be very good at it. All right. See, many students, what mistake many students do is, you guys just keep reading about your uh, theory part. All right, that is not good. You need to you need to practice questions. You need to practice questions in order to have some good clarity. All right, Adri, I'll come very soon. I'll come very soon. If you plan to buy the subscription plan, you can just apply this code Nitesh YT. All right, just apply this code Nitesh YT. You'll have 10% off. You'll have 10% off. All right. Okay. Shall we do some practice? We have studied today your de Broglie wavelength, and we have studied your Heisenberg uncertainty principle. Let us do some practice. Okay, okay, Artery. Great, great. Yes. Okay, let me give you some questions. Let me give you some questions. Okay, fantastic. I'll continue here, Nishta. I will continue here. Don't worry, I'll continue here. I will continue here. Alright? Question is the velocity, assuming the velocity to be same, assuming the velocity to be same, the wavelength, the wavelength of waves associated with which of the following, which of the following particles would be maximum. I'm giving you options also, don't worry, I'm giving you options. Yes, the first option is electron, second option is proton, third option is alpha particle, and your fourth option is neutron. Fourth option is neutron. Come on everyone, try this question. Yes, what? Yes everyone, attempt this question. Pretty easy questions are being asked from these two topics. All right, the question is pretty easy which are being asked. Yes, which phenomena it is talking about, which phenomena it is talking about, which phenomena it is talking about. Just like this video guys if you are able to understand everything. Yes, all right. It is talking about de Broglie wavelength. Lambda equals to h upon mv. Now see, velocity, it is saying velocity is same. Velocity is same. You need which of the following particles would be wavelength. Wavelength you need to have maximum. For wavelength to be maximum, for lambda to be maximum, your mass should be what? Minimum. Your mass should be what? Minimum. Yes. So mass is minimum for what? Electron. This is very much known to you. So first is your answer. Very good. First is your answer. Perfect. Perfect. First is your answer. Electron is your answer. Correct. Great, Nishtha, Rahul, Atri, Supriya, Kunal. Fantastic. Is this thing clear, guys? Is this thing clear? Is this thing clear? All right. Great. Great. One more question. Are you guys ready for one more question? Are you guys ready for one more question? Fantastic. Fantastic. Yes, 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 yes. All right. Question is two particles A and B are in motion. Two particles A and B are in motion. If the wavelength, if the wavelength associated with A is 5 into 10 to the power minus 8 meter, calculate wavelength, calculate wavelength associated, calculate wavelength associated with B if its momentum, if its momentum is half of A, if its momentum is half of A. Come on everyone, try this question. Momentum of B is half that of momentum of A. Yes. I need answers from every student. I need answers from every student. Come on, everyone. Attempt this question, guys. I'll give you the answer. All right. The announcement is. I was giving you. I was able to. I had to give you some announcement, na? Yes. Uh, on Monday, on Monday, at your 5 p.m. in the evening, 5 p.m. evening, you have your special class. You have your special class on our Unacademy platform or our Unacademy platform. All right. Monday 5 p.m. All right. We will be discussing about the NEET 2020 paper. We will be discussing about NEET 2020 paper. All right. As well as we will discuss what all things you need to do in order to get some great marks in your 2021 exam. All right. We will analyze the paper of your 2020. All right. A brief analysis, uh, and then your NEET 2021 also. All right. Actually, no issue. You can watch the recorded lecture also then. Okay. Just follow. Just search my name, Nitesh Devnani, and follow me on your Unacademy platform. We will be having regular classes now there. All right. Follow me there. All right. Yes. Yes. All right. Okay. Is the announcement clear to each and everyone? Monday 5 p.m. evening. Monday 5 p.m. evening. Okay. All right. Now see this question. It is being given to you. Momentum of B is half of momentum of A. So this is given. This is given. Yes, yes. Special classes are free classes. Special classes are free classes. Hello, Babita. Special classes are free classes only. Yes. All right. So you can write it as PA equals to 2 times PB. Correct? Correct? All right. Now see. Now just pay attention here. Lambda A equals to H upon PA according to your de Broglie wavelength. Lambda equals to H upon P. Lambda P equals to H upon PB. Correct? Just divide these. Divide these. H and H cancels out. Your lambda A upon lambda B equals to PB upon PA. Correct? Lambda A is given to you as 5 into 10 to the power minus 8. Lambda B you are being asked. All right. Now see, PB upon PA. PB upon PA is 1 by 2 is PB upon PA. Correct? PB upon PA is what? 1 by 2. So simply write here 1 by 2. So lambda B is coming out to be 2 into 5 into 10 to the power minus 8, which is 10 into 10 to the power minus 8, which is 10 to the power minus 7 meter. Is this question clear to each and everyone? Is this question clear to each and everyone? All right. Great, Supriya. Yes, yes. Great, Alakya. How many of you were correct? Give me thumbs up in the chat section. How many of you were correct? No issue, yaar. If you are wrong also, there is no issue. You just need to learn from here. That yes, you are learning, you are growing. All right, great, Balaji. Yes, yes. At 9:30 a.m. we have our regular classes. Uh, at 9:30 a.m. we have our regular classes. All right, at 9:30 a.m. try to attempt, try to attend on time. All right, please come on time. Yes. No issue, Keshav. No issue. Slowly and gradually you'll get things. See, Anna, how many of you know how to how to play guitar or a music instrument, or you are good in any sport? All right, if you want to be good at anything, if you want to play your guitar very good, if you want to be very good in your games, if you want to be very good in chemistry, all right, great things take time. All right, great great things take time. Great things take time, guys. All right, all right, you just need to do PPP, means practice, practice, practice. Things will automatically come. You will be very good in chemistry. You just need to practice. All right, all right. Any doubt in today's class? Any doubt in today's class, guys? Like this video if you are able to understand everything. I'm again repeating, at 9:30 a.m. we have our regular classes, your Monday to Saturday, your Monday to Saturday. Yes, Rahul, fantastic. Yes, Atri. Okay, any doubt? Two classes more, Anisha, and we'll be finishing this chapter. Yes, Keshav. Great, great. Great, great. Yes, Nishtha, great. And the doubt thing is a bit difficult. Doubt thing is a bit difficult. All right. Yes. Any doubt right now? If you have any doubt, you guys can ask me. Any general doubt? I've explained. I've told you about my special class, guys. I've told you about my special class. A special class would be at Monday 5 p.m. All right. Monday. You have your Monday, your 5 p.m. special free class. This is a special class. All right. Special classes are what? Free. Special classes are absolutely free. Okay. Special classes are absolutely free. All right. We'll have some analysis of your NEET 2020, the paper which we'll some analyze that, and we will also do what 2021 can expect from you all. All right. So just follow me, Nitesh Devnani. Just follow me there on your Unacademy platform and share with your friends. All right. Tell them about our special class. Share with your friends. Help as much students as you can. All right. You just need to share things. All right, in your friend circle. Yes, Nishta, great. Rahul, practice. You can take any book. All books are good. You can just practice from any book. All right. Yes, Priya. We will talk about a schedule also in this special class only. We'll talk about schedule also in this special class only. All right. I'll talk about schedule also. Just attend this class. Share with your friends so that lot more students we can help. All right. And again, I'm telling you, whenever you are planning to buy the subscription plan, just apply the code Nitesh YT. If you go for iconic subscription, I can be your mentor there, and I can help you throughout your journey. All right. 10% off also you will be getting if you apply the code Nitesh YT. All right. Okay. Monday 5 p.m. special class. Everybody needs to come. I want to see all of you. Priyav, Keshav, Priya, Keshav, Amisha, Nishtha, Rahul. Alright, Atri, Ilakya, Supriya, Mofika, Balaji. I need Babita. I need everyone there. Alright. Yes, yes, we'll study in English only. We'll have a special class also in English only. Yes. I want you all there. All right. I want you all there. All right. In our a special class. All right. And I need your friends also. I need your friends also. You are going to help me. Help by helping means you are going to share this thing with your friends. All right. No, no, Atri. Just see whatever is comfortable to you. All right. All right. Yes, yes. All right. So just help me also share with your friends so that maximum I can reach maximum students and we can increase our student base. All right. Yes. All right. All right. So I will see you tomorrow morning 9:30 a.m. That these classes are regular. 9:30 a.m. These classes are regular. I'll see you tomorrow morning. All right. Great. Bye bye. Bye bye guys. Take care. Have a great day and practice questions. All right. From your Heisenberg and your uncertainty principle. Practice some questions. Okay. Bye bye guys. Take care. Take care. Bye everyone. Bye. Bye everyone. Bye guys.